students, how are you all? I hope you are fine and staying safe. Today we will start with a new chapter called probability. But before that, let us recall what we have learned in class 9. We have learnt the definition of probability, that it measures the uncertainty of an occurrence of an event using numbers. Then we have learned some terms associated with probability such as event, outcome, experimental probability and frequency. To find the probability of any event, you have also learned the formula which is denoted as PE equal to the number of trials in which the event E has happened divided by the total number of trials. Lastly, you know that probability of any event lies between 0 and 1. In this chapter, we will extend our understanding of probability and try to learn its significance in real life. We will differentiate between experimental and theoretical probability. We will learn some new terms associated with this topic such as elementary events, complementary events, an impossible event and a sure event. We will also try to find the probabilities associated with such events. You know that probability has a wide application in our daily life. It is used in weather forecasting, devising sports strategies, insurance business, in financial markets such as stock market, commodity exchanges and currency market, in survey analysis such as election results, census survey and entertainment reviews, in devising business strategies, in traffic management, scientific and medical research, impact on economy, and last but not the least, it has a wide impact in our decision making in our day-to-day activities. Let us understand what an experimental probability is. The experimental probability is based on actual experiment. We need to conduct a large number of trials. For example, if we toss a coin 500 times and note down the readings of head appearing 275 times for example and tail appearing 225 times, then we find the probability using this formula. We get the probability of H as 275 divided by 500 and the probability of tail as 225 times upon 500. Now, let us understand what a theoretical probability is. The theoretical probability is based on possible outcomes of an event which are equally likely to happen. So, what do you mean by equally likely events? Equally likely events are those events whose outcomes have the same chances of occurrence. So, kindly note the phrase same chances of occurrence. That means each outcome is as likely to happen as the other, and so the probability of each outcome is same as the probability of another outcome. Let us understand this concept of equally likely event with the help of an example. Suppose we have a circle which is divided into 4 equal parts, each having a different color, and if we spin this arrow, then this arrow has an equal chance of stopping at either of the colors, right? This is an example of equally likely occurrence. In figure 2 and 3, see, we have a greater portion of purple color and a very less portion of blue color, right? So, if we spin the arrow, then this has a greater chance of stopping at purple color and a very less chance of stopping at blue portion. Similarly, in figure 3, the arrow has a very less chance of stopping at black color. So, this is an example of unequally likely occurrences. Let us consider one more example. If we toss a coin, both head and tail have equal chance of occurrence. That is, getting head or tail is an equally likely event, isn't it? Other examples include rolling a die, getting a number up to 6, drawing a card from a well shuffled pack of 52 cards. You know that a pack of cards has 26 black cards and 26 red cards. It has 4 suits called club, heart, spade and diamond. Let us find the formula of theoretical probability. This is nothing but PE equal to NE upon NS, where NE is the number of outcomes favorable to E and NS is the number of possible outcomes. Let us take an example. We toss a coin. What are the possible outcomes? Outcomes are nothing but head and tail. So, the number of possible outcomes is 2. Let us suppose that the event is that we get a head, right. So, NE becomes 1. Let us find the probability. The probability is PE equal to 1 by 2, that is the number of outcomes favorable to E upon the number of possible outcomes. Let us understand elementary events. In an experiment, if all the events are equally likely to happen, then such events are called elementary events. For example, when we toss a coin, we have same chances of getting head or tail. That is, we have already learned that probability of heads is 1 by 2 and also the probability of tails is also 1 by 2. Note that the sum of probabilities of head and tail is nothing but 1. Let us consider another example. If we have a bag and there are 3 balls in it, each of yellow, green and white color, then each of these balls have an equal chance of getting selected. Then we get that probability of yellow ball, probability of green ball and probability of white ball is nothing but 1 by 3, 1 by 3 and 1 by 3, and see that the sum comes to 1. Now, we will understand a new topic, complementary events, with the help of an example. In a single throw of die, let E be the event of getting number less than 3 and F be the event of getting numbers 3 and above. We can also say that the F is the event of getting numbers not less than 3. Then F is same as not E and it is denoted as E bar. So, the probability of E is 2 by 6 as the numbers are less than 3 and the probability of F is 4 by 6 since we have numbers 3 and above. This implies probability of E plus probability of F is 2 upon 6 plus 4 upon 6 equal to 1. We replace F with E bar and get the same result. We interchange the positions and get PE bar equal to 1 minus PE or PE equal to 1 minus PE bar. What do we see? We see that the events E bar and E are complement of each other and the sum of probabilities of complementary events is 1. Let us do an exercise. If PE equal to 1 upon 3, then what is PE bar? Simply it would be 1 minus 1 upon 3, which is equal to 2 upon 3. Let us consider another example. If PE bar is 2 by 5, then what is PE? Simply it would also be 1 minus 2 upon 5, which is equal to 3 upon 5. Similarly, students, I request you to find the next 2 options yourself. Let us understand what an impossible event is. Again, we consider an example of rolling a die once. So, what are the possible outcomes? We know the possible outcomes are 1, 2, 3, 4, 5 and 6. Can we ever get 7? Have you ever seen a die with 7 dots? Thus, getting 7 is an impossible event in a single throw of die. Let us find out the probability of an impossible event. Since getting 7 is an impossible event, the favorable outcome of getting 7 is 0. Thus, probability of 7 is nothing but 0 upon 6 equal to 0. We infer that probability of an impossible event is 0. Let us understand what a sure event is. Again, we will take the same example of throwing a die once. Do we always get a number less than 7? Yes, we always get a number less than 7. Such type of event which is sure to happen and which is certain is called a sure event. So, what is the probability of such a sure event? Let us find out. Probability of getting a number less than 7 is nothing but number of favorable outcomes divided by the number of all possible outcomes, which is equal to 6 upon 6 equal to 1. So, again we get another result, that the probability of a sure event is always 1. Let us recap. Probability of an impossible event is 0 and probability of a sure event is 1. So, what is the probability of any event? The probability of any event lies between 0 and 1, and mathematically we write it as P any event E or just PE greater than equal to 0 and less than equal to 1. Now that we have studied so much, let us do an exercise. Question 1. Probability of an event E plus probability of an event not E is equal to dash. What is it? Yes, you are correct. It is 1. Question 2. In an experiment, the event that cannot happen is known as dash event and its probability is dash. Yes, this is an impossible event. The event that cannot happen is an impossible event and its probability is of course 0. Next question. In an experiment, the event that is certain to happen is known as dash event. Of course, sure event. Certain and sure are synonyms. The sum of probabilities of all elementary events of an experiment is dash. Of course, you are correct. It is 1. Next question. The probability of an event that is certain to happen is, of course, it is 1. Certain means it is a sure event and the probability of a sure event is 1. Next question. Which of the following is correct? Here we are given 4 options and we need to find the probability of an event. We know that it lies between 0 and 1. So, our correct option is option A. I hope you have understood the concepts and session very well. Thank you.